Okay, here we go. Let's give this a try. So first thing we're gonna do, we have a blank slate on this one. This one is the check of the problem here. We have 33n cubed minus 121n squared. So we're going to break this apart into as many pieces as we can. Remember, we're thinking about prime numbers. That means 1 and itself goes in. 33 is a really nice one because the only two numbers I can think of are a 1 or a 33 and 11. Or sorry, 3 and 11. So those two numbers, 3 and 11, are both prime. So we're off to a good start here. So 3 times 11. Okay. And then I need n times n times n. Break those three n's apart. Okay, so let's do the 121. So 121 is a little bit harder of a number. I personally know that it is 11 times 11 to make 121. And luckily 11s are both prime numbers. So I can just do the n times n and then be good to go. Okay. So I'm going to go ahead and circle what they have in common. So let's see here. I see the 11s and two n's. So I know that's what's going to be out in the front of my parentheses. Now, in the last example, they had that extra step where they wrote it in parentheses and then again. You could skip straight there and write what's left over. That's totally fine. Okay. So that's what I'm going to do because I don't want to do that extra step. So I see 11n squared. That's my GCF, my greatest common factor. It's the biggest number I can take out of each of the two pieces. And then I'm going to write what's left. So the top, which is coming from the 33, has 3n left. And then the bottom, which is coming from the 121, has, oops, and I forgot the negative on that 11. Sorry. Negative 11n. Actually, no end. N's are gone. We used them. I got to erase this. So there we go. And there is our factored using GCF. Now, if you wanted to check this, distribute the 11 squared n squared back in, and you should get back to this original problem. Let's go ahead and keep in the same video, and we'll go ahead and do the next one. So this is a three-parter, so it's going to have a little bit more work with it. So let's go ahead and list out the GCFs for each piece. 14. 14 I can break apart as 2 and 7. Okay, 2 times 7. And then I want to go ahead and list out all those letters. So AA, BB, and a C. AA, BB, and a C. Okay. 6 can break apart as 2 and 3. I see 1A and I see 2 C's. Okay. And then 10 can break apart as 2 and 5. Both of those are prime numbers. And I see an A and I see a C. Now remember, with a three-parter, it has to be in all three pieces. So I see 2's, I see A's, and I see C's. And I'm going to go diagonally. There we go. So I know the greatest common factor is 2 times A times C. 2AC. Okay. Now I got to write what's left, starting from the top to the bottom, because that's the order in which it's being written off to the side over here. So I see for the first one, 7A and then B squared. Might run off the page here. I'm seeing, oh, I did it again. I forgot that negative. Do not forget that negative. The 3 is going to be that negative sign. Okay. It makes it so that when you distribute it back through, it gets a negative back to the beginning. So -3, C for the middle, and then 5 for the end, +5. Yeah, do not forget that negative, super important.